Okay, we're about ready to study angle relationships, so we're going to do a geometry lab with some paper folding to investigate these angle relationships. So take your piece of paper, and you're going to fold your paper any which way you want to. Okay, folded my paper. I'm going to take my ruler, and the only thing my ruler is for is to trace on here my crease. And I'm using a very dark color, so I chose black so it sees through my paper a lot better. Again, I want it to go through the paper so I can see it on the other side. So I'm going to go over it twice. Okay, this is a line. Little arrows on the end signify it's a line. This is going to be line A, B. Okay, so I have line AB. Then I'm going to crease my paper again some random way. And again, I'm going to trace my crease. Going over a couple times so I can see through. I might want to make sure this goes off the edge because I'm going to be looking at where some things line up. And then I'm going to name this one, and this one is going to be, if this is a B, I'm going to put a D over here, and I'm going to put an E over here, and I'll take this intersection and name this intersection C. Okay, so I've got two intersecting lines. They intersect at point C. And now I'm ready to start folding and look at relationships that I see. So if I look at angle BCE, and I fold angle BCE on top of angle DCA, what do you think is going to happen? Now, let's fold it and see. So I'm taking BCA, or BCE here, and I'm folding it so it is on top of, and maybe it's easier if I do it this way so you can see it, ACD. So whenever I fold it through C, you should see that it lines up exactly, right? It goes through this and straight onto the other one, so they are the exact same angle. They're the exact same angle lined up on top of each other. They are the same measure. So I know that this angle right here and this angle right here have the same measure. If they are the same measure, we know they are congruent. So I know that angle DCA and angle BCE DCA are congruent. Congruent just means they have the same measure. Likewise, if I fold this the other way and I put this top angle, this DCB, on top of AEC, so I'm going to fold my paper this way now. It's easier for me to fold it, so I'm lining things up here. Get C in the middle here, and I want to put this edge there. Make sure my edge is on top of that edge. Maybe it'd be easier if I just line up this edge and my C. If I line up this edge and the C and I do it right, they both should line up. Okay, so ACE has to be the same measure as the one that it's on top of. See, it comes straight through here. And you can see it coming out the edge right over here as DCB. So I know that this angle here is the same measure as this angle down here. And know that our notation, if it's got one arc and one arc, that they are both the same measure and are congruent. And if these two have two arcs, then this one up top and this angle down below are congruent and have the same measure. So I just did angle BCD, angle BCD, BCD, and angle ACE, angle ACE, and I decided that those two were congruent. Because when I folded them, they landed exactly on each other, so they had to be the same exact measure. So the next thing I want to do, I've labeled everything. I want to talk about vertical angles. So these two angles are considered vertical to each other. They're two intersecting lines. They have the intersection point of C, and they form these two angles, and these two angles have to be congruent. So this is a set of vertical angles. DCB is vertical to ACE, and DCA is vertical to BCE. And you're used to thinking of vertical being up and down. All I got to do is turn this, and these are now up and down. Vertical in here means across the vertex from each other when you have two intersecting lines. Okay, so these are both vertical angles. And if I take a protractor, we can actually measure these angles. And to use a protractor, let me zoom in here. So here's my protractor. Maybe I need to zoom in just a little bit further so you can see the protractor. So on my protractor, here is a line right here. And on the other side, there's a line at the edge. And if you follow to the middle, there's a straight line here. And that's actually where 0 is. 0 is not the edge of this protractor. It's coming straight through, kind of in the middle of the base. And then you have this vertical line right here with a hole. That hole is where you put your vertex of your angle. And then you put 0 on the edge of one of your lines. So if I put the hole on my vertex, and then I have to line up this edge so it's on my line. Okay, once I have that, I'm at 0 here, I'm at 0 over here, my vertex is right on my vertex. Then I can measure. If I measure from this side going around that way, well, I'm not going to start at 170, 160, I'm going to start at 0, 10, 20, 30, so I'm using the inside numbers. Okay, so the inside numbers, and if I come up here, I'm between 60 and 70, and this longer line here is 75. So 76, 77, I think I'm at 78 here. So let me measure this and call this 78 degrees. And then I'm going to measure this one on the other side. So if I'm starting here, again, I'm not going to start 170, 160, 150. I'm going to go 10, 20, 30. So I'm using the outside of the protractor coming the other way. And I'm just past 110. So 110, 111, 112. I am at 112 degrees on this side. Oh, this is 68. Silly me. Yeah, it's between 60 and 70, so it's 68 degrees. That's 68 degrees. Then I'm going to flip my protractor, or I'm just going to flip my paper. And I'm going to measure the other way. Again, to line up the protractor, this center goes on my vertex. And then I want my 0 to be on my line. So I'm going to move that around. And the 0 on the other side should be on my line because it's a straight line. All lines are straight. Starting on this side, I'm moving the inside numbers because it goes 10, 20, 30, 40 inside numbers. Again, I'm between the 60 and the 70, and I'm just shy of the 70, so I am at 68 degrees here. And coming around the other side, I'm going to use the outside numbers because that makes sense. This is 10, 20, 30, 40. Using outside numbers, this is just past 110. So 110, 111, 112. I'm at 112 degrees there. And so you do in fact see that DCA was 68 degrees and BCE was also 68 degrees. These were 68 degrees. And that here's B, CD, BCD, that's this one, and ACE are both 112 degrees. They are in fact congruent. Okay, so these both were 68 degrees, these both were 112 degrees. They are congruent. They are considered vertical angles. Okay, vertical angles, they go across the vertex when you have two intersecting lines. Next thing we want to look at is what happens to the angles that are next to each other. And do they have a special name? Well, yeah, the angles that are next to each other are called adjacent. So angle ECB is adjacent to BCD because they have the same side and the same vertex. And we call them a linear pair. These are a linear pair because they form a straight line. Okay? If you take this angle over here and you put it next to this angle, they line up and you get a line. So in here we have angle, I'm going to go ECB, and then I'm going to look at angle, I need to go out a little bit further so you can see this, BCD, angle BCD, BCD. Those two angles, if I add them together, well, this one, the ECB, is 68 degrees, and BCD is 112 degrees. You get 180. Well, is that true the other way? If I look at these two down here. This is ECA, so angle ECA, and I add it to ACD, ACD, so ECA is 112 degrees, and I'm adding it to ACD, which is 68 degrees. And if I add those together, I do get 180 degrees. Okay? So these two form a linear pair. So these are a linear pair. Linear has the word line in it, and pair, so it's a pair of angles that form a line. So take a moment, write down a rule for that. What are vertical angles and what are a linear pair, so that you know that, and hopefully this folding activity has helped you along the road for that understanding.